Destructuring data in Rust. That sounds complicated. It seems like it's a computer science term that allows us to do advanced technology. It really actually is pretty straightforward. It simply lets us take data from one part of the, like maybe it's a variable or the output from a function, and then assign it to multiple variables. That's it. That's what destructuring is. It's a really, I've seen this so many times in languages like Python and even JavaScript. It lets you assign data from one thing and then sort of span it out to a few other variables, which is really nice from a readability perspective. As you know, as humans, we need to code and we need to read the code. So destructuring is really beneficial. So if we take a look at, say, for example, a tuple will have, it's basically a list, right? A tuple's a list of it's an untyped list. You can have all sorts of data in here. You can destructure a tuple using this pattern, triple. Here we go. And then basically assign data like this. We can use this pattern. This is destructuring. Really straightforward and simple. And there's no errors. No output. No output is good in this case because the compiler's like, you did a good job. You can also, you might not know if the tuple is super only 3, right? You might not know that it's 3 elements long, or you might only care about the first 2 elements in the tuple. So you can do this as well, right? Where you do the dot dot where it says ignore the rest, and that will also give us a good output. So in using the match keyword, it's basically the same. You can do exactly the same. It's really powerful. It's also this is, in other languages, you have the switch statement, which, it does what it does. It's kind of like a shorthand of the if-else in a series, and that's what a switch statement is, and this doesn't get much more complicated than that. With a match statement, it's very powerful. It lets you do things like this, which is like, hold on, what's going on here? So we have the triple, which is 3 numbers, right? 3 assigned number. We've got 0, -2, and 3. Well, say under the case where you want to capture, where the first element is 0, and you want to capture the data of the other 2, you can say YZ, and now you can print out 0 and the data from YZ just with this. It's such an amazing shorthand. Often I was thinking, oh, Rust is verbose. It's got, it's a typed language, so it requires a lot. Well, do you see any types here? I don't see any types. I don't see any representation. It's all automatically understood that through inference that these are 32-bit numbers. Oh, it's so good. I like that. It's fantastic. This is, if you were to say, Steven, what's your favorite keyword, like statement in Rust? What is your favorite? It's going to be the match. I love this match. The match is the best. I use it all the time. It is my #1 favorite thing because you can do things like this. It's shorthand, it's easy to understand, easy to read. It does all the things. It's fantastic. Oh, check it out. Okay, so if you also wanted to check to see if the first element is 1 and you don't care about anything else, then the rest doesn't matter, but the first element is run. You can do the same thing with the last element. You must check the last element of the tuple. If the last element is 2, but you don't care about anything that comes before it, you can use that pattern. You can even go in the middle. So if say the tuple is 10 elements long, you can check the first and the last element for certain data, right? The first element has to be 3 in this case, and the last element has to be 4. Then this statement will run here. And apparently you've got this double dot and an underscore. Are they the same? Okay, hold on. What if we did this? What's gonna happen? All right, we have to test this out really quick. Is Rust gonna be okay with something like this? I don't know, I've never tried it before. All right, it doesn't like that syntax. What if we put it in the tuple format? It has to like it now, right? I mean, it's following the syntax pattern. This has to work. Unless it's saying, oh, you've got two of the same thing. That, I expected to say something. Oh, it worked anyway. What's going on? Let's see if it prints. Let's see if it finds this here or if it goes to this. Which one takes precedent? Oh, it took this one first. Interesting. We're gonna play with this for a little bit. Order matters. So the first one that it runs into that it matches is going to match. And there's definitely crossover. This is interesting. This might be a very special case. What if we tried to duplicate this 0, comma? Is that basically we're duplicating this match here with this? Because they would match the same. Is it going to work? It does. Oh, wait. Hold on. In this case, it was that. Okay, here we go. That's interesting. Okay, so they are different. What if we just straight up duplicated it? Is Rust gonna let us do this? Okay, well, all right. Well, just in case you thought, okay, So the compiler won't check to see if you've got duplicate match statements, but it will check to see if you don't have fully exhaustible match statements. Oh, and just in case we didn't talk about this, the underscore, any variable name that is prefixed with an underscore, including a whole bunch of other underscores, it's a placeholder. We're saying, yeah, there's probably data that's going to come back here, and we're going to ignore that. We are not going to capture any data. We just want to ignore it. And yeah, you can have as many underscores as you want, and it works. There's all languages that are just so fun, the more things you get to learn. Even though it's clean and organized, it's a really weird looking, I would say. This match statement that lets us destructure data through a variable, it just looks odd, and also it's clean. It looks really clean, I get it, but it's also at the same time, it's like, what's going on? I don't know what this is. But once you get used to it, it becomes your favorite. And it's an approach that you'll want to use constantly going forward. So what we have here is an array with 3 elements. They're going to be numbers, 1, -2, and 6. We're going to match on that array, right? Our match statement is like a switch statement. It takes data and is able to apply it over these rules. And the first one to match will win in this list. So I can see here that this is going to match first because we've got the first element is 1. So this match statement here, 0, well, it's not 0, so it can't match on this. So this one is a 1. It also says ignore the middle one, and then assign that data through destructuring. So 6 here. So that will print out, this will be the one that prints. Let's find out if it worked. It worked. Okay, so that's the pattern. That's what we were looking for. Oh, what is this? What's going on here? We've got some sort of @ symbol. That is an unexpected addition. Okay, now we're in unknown zone. What's going on with this @ symbol? Oh, no way. Okay, so this is helping us. This is like a let statement of some sort that lets you take a slice of the remaining portion of the array and assign it to a variable. You want to capture, so you want to match on the first element must be equal to 3. Assign, through destructuring the second element to this other variable called second. And then you can also assign the remaining set of because arrays that, how long are they going to be? We don't know. They could be very long. You want to assign the rest of the data through a slice definition on the let binding with this @ symbol to the rest. That is interesting. That is really cool. So in this case, that would be 6, right? So tail would essentially just be an array with 1 element, and the last element would be 6, right? Because we saw that the 6 is up here, it's the last element. But if we, had a whole bunch of other numbers, it would be assigned to the rest of them. You can even do that with the middle data. No way. Okay, this is cool. So you can have the first, all right, so here's the catch-all. All right, so we're gonna take the data, and this will be the last matching statement, but it'll also capture every sort of remaining element because it's not matching on anything specific. So it's going to assign the first element, right? The first element's going to be 1. The middle element and anything in the middle. So we've got our last element, which is going to be number 6. On either side, if there's more elements, it's going to capture the middle part of it. That is really neat. So this will be an array. This should be a number directly, right? This will be a number, but this will be an array itself, essentially a slice, right? So we're slicing the array. So that's why we've got this middle. That is so cool. All right, let's see what that looks like. All right, so as you can see here, we see that we've got the number 1. We've got a slice of an array, which is going to be 2. So you see these brackets. So this @ symbol is going to give me an array. And then the number 6, which is the last element. But if we add more, let's add more -2s in here, right? Get a few more -2s. Our middle will be all these -2s. And here we go. Look, we've got 3 -2s now because they are in the middle. I wonder where it's nice to know that we could have this, that it works like this. Someday you might run into a scenario where you'll need it.